When using a laser beam in a real-world application, such as a medical application, you obviously want to be sure the beam arrives at the target. If the laser beam happens to be invisible though, say an infrared beam, aiming it is not a simple matter. The usual solution is to use a visible aiming beam and then to set things up so that the application beam goes exactly where the aiming beam goes, or to align the two beams. How do you do that? In this video, we'll walk through a simple step-by-step procedure. The key to the concept is to work systematically. Step 1. We use a beam splitter to combine the application beam with the aiming beam. We begin by setting it up so that the two beams meet at one point on the splitter and continue from there. Of course, some of the aiming beam will pass through the splitter, and some of the application beam will reflect off it, but by choosing the splitter carefully, any effects of that can be minimized. We use an infrared phosphor card or a ceramic target to see the spot from the IR beam together with the visible spot from the aiming beam. In this step, we place this IR card close to the splitter, and we adjust the aim of the visible beam so that we bring the two spots on the IR card together. That gives us a preliminary alignment. Step 2. Now that the two beams are at least approximately aligned, we move the IR card farther away and place it near where the target in the live application is actually going to be. We now look at the two spots, the IR and the visible, on the IR card. Because we're farther away now, the two beams, which were only approximately aligned, are now again separated. Had we not done that first step of preliminary alignment though, we'd most likely not be able to get the two spots onto the same IR card at all. Step 3. The two beams are connected at their starting point and are separated only angularly. We can bring them together by adjusting two angular degrees of freedom of the splitter. If your application involves a lens, we now move on to step 4. We place the lens in the beam, or actually beams. If the beam is off of the lens axis, there will be a deviation. Keep in mind, by the way, that the two beams may experience different deviation here because of chromatic aberration. We'll know it for what it is though, because the two beams were aligned without the lens. Step 5. We adjust the lens's XY position to bring the spot, or the two spots, back to center. And there we are. You can see how by separating the problem into steps and working systematically, locking down one degree of freedom before starting to tamper with the next one, we avoid situations in which multiple parameters that affect each other need to be adjusted at the same time. For more information, please visit our website or contact your local Ophir representative.